Hello everyone and welcome to a new video of Web3 hacking and development tips. So I got this contract from OpenZeppelin. I hope that I'm pronouncing it right. So this contract is called this contract, as you can see, called Fallback, and we are going to we need to become the owner of this contract. So let's go through the function of this contract step by step. So this contract is called fallback. We have a mapping here, addresses to uint 256. It's public and it's called contributions. Address public of the owner. Okay. We have a constructor, owner, message sender. We have contribution of the message sender, which is the owner of 1000 Ethereum. Here we have a modifier, only owner. Modifier require message sender equal owner, equal owner. Color is not the owner. Okay, we have the first function called contribute. It's public and payable, which by payable it means that we have to send some ETH with this function, and it has a require message. The value of the Ethereum that you are going to send to this function must be less than 0.001 Ethereum. The contribution of the message sender will be added each time for this line. Whenever you send Ethereum, it will add the value to you. It means whenever you send any amount, they will be added as a sum. And here, if contribution of the message sender more than the contributions of the owner, the message sender of to this function, the wallet, whomever is, will become the owner. Okay, so you have to send more than 1000 Ethereum to become the owner of the contract. Here we have a function called getContribution. It's public, view returns. It return to you your contributions, your total contributions. Here we have a function withdraw public only owner. Payable transfer address, this balance address of this contract, all the balance to the owner. And here we have receive function external payable. So we can send some Ethereum, this function, so we can be able to send some Ethereum to the contract. And this function has a logic here. To send the Ethereum require the value more than 0, and already you have a contribution more than 0. So when you do that, you fulfill these two conditions, you become the owner. Okay. So let's start. So here I have my my VS Code. So I'm gonna do this. CLS. Okay, here if you see my previous video, you would see what is that exactly, but I will re-explain it again. This is a hardhat project, and I put a virtual Python environment within it. So I can use Python, and I can use hardhat features like running a local node, for example, to have a local blockchain on my machine. So yes, so let's start first thing first by running we are here in hardhat. Okay, let's run a npx hardhat. Let's do node, so we can have a node running. Okay, and let's get back here to our virtual Python virtual environment, and let's start by deploying the contract. Error while querying provider failed fetch. I think I need to reload this. Okay. See what's the does not reload. Yeah. Okay. So contract, where is it? It's called fallback. Okay, and let's compile it. It's compiled. Let's go to deploy hardhat. Okay, so we have hardhat here, and we can see the wallets. And then what we should do, we should deploy the contract. Let's go up here, and let's do first wallet. I want to deploy with the first wallet. Deploy. Okay, so our contract is deployed at this address. Okay, and let's go down. This is the function, all the functions of the contract. So let's interact with this contract here on Remix. Let's go to the second address and let's do the contribution. Let's contribute. We need to contribute less than 0.001 Ethereum, else the function will be reverted, and here they will not show us the message. Why it is the reason. They will say the function will be reverted with no reason. So let's put way, and let's put one way. For example, we are going to contribute with one way, and let's say contribute. Yeah, okay, and we receive the one way here. If we do one ETH, for example, let's see what's gonna happen. Okay, one Ethereum and contribute, and there is a problem. Cancel transaction, send the transaction estimation gas order. There is a gas order estimation transaction. I don't know this problem exactly. Revert. Okay, let's cancel the transaction. We don't need it. If the transaction failed for not having enough gas, try increasing the gas limit gently. Okay, I will not do that. So here, get contribution. If we take this wallet, for example, our wallet, and we do get contribution. No, our wallet, we get contribution. Yes, this is our contribution. Here, the function contribution, this is the mapping contribution. Okay, so if we go back to this, copy, and do this, we will see too much. 1000 Ethereum. It's a lot of money, and the owner is still the first one. Okay, so we need to move the owner from this first wallet to the second one. So what we should do, we have just to understand the logic. There is a function here say that if your message value is more than 0 and your contribution is already more than 0, you can become the owner. So this wallet has already contributed. If we do contribution, we have already contributed. So we have to fulfill the first one. Just we have to send some ETH. Let's send some Ethereum, 1 ETH. And it's receive function. Let's send some ETH. Okay, this is the owner, and this is our wallet. The owner is still okay. We have 1 Ethereum here, and we have already contributed, and now we just need to send 1 ETH, for example, or any amount. It must be more than 0. That's all, and we'll become the owner. Let's do that. Transact. Yeah, successful. Transaction has been mined. And if we go to owner again, we will see our address. We are the owner of this contract. So I believe, guys, that you understand the logic of all this, of this smart contract. So now what we are going to do, we are going to use Python. This part I love in the hacking of the smart contract. So we are going to use Python to interact with the smart contract and perform all the functions and call all the functions and do everything to become the owner, not through Remix, but using some Python code. So let's start. So everyone, here we are on our within our hardhat project. We created a virtual Python environment. So let's start. This is VS Code, as you know, and we are going to create a new file. First hardhat, I named it. So let's call it Fallback. So first thing we need to do, sorry for that. First thing we need to do is to import Web3. Okay, from Web3 import. Okay, this is the first thing that we should do. We initiate a variable Web3. It's Web3. Sorry. Again, Web3 HTTP provider, and our provider is it's HTTP locally. The port is 8545. You can see that, you can see this when you deploy the smart contract. So there is something that I always do. It's, sorry, if W3 is with me is connected, just print, okay, else print not. And we are going to provide our contract address, which is W3 to checksum. I explained this last time in the previous video. Everything, every line, this is like a template. This code that I'm writing, it's template, and you are going to use it every time with every contract that you are going to interact with. So my address, the address I'm going to use W3 to checksum also. Okay, first, and we have our private key equal. Okay, so now what do we need? We need the ABI of the contract. So let's get back to Word here. We go to Solidity compiler, ABI, we press here on ABI, copy to clipboard. We get back to our contract and we just do paste. And now we have our ABI. Okay. Save this. Let's go back to our node. We are, I believe this address deployed. What is it? Is it deployed? Yeah, it's deployed on this address. Let's copy this address with this owner. My contract address is this one. Let's take, because it's deployed with this address, so let's take the second one as our address, and we are going to interact with the contract. Yeah. Private key also, we need the private key always. Let's put it. So everything is set. Now let's start. So first thing first, we are going to contract instance is W3 if dot takes the address, which is contract address, and pick ABI, which is our ABI. And now what we want to do. So we want to become the owner of the contract. So okay, only owner, we cannot do anything. So first thing first, we need to contribute. So this is the function, it's contribute. We need to contribute. It's a public payable, so we don't have any here variable to send with the function. So, and we need to send some Ethereum, which means we have to build a transaction to send it along with the function. So let's do that. CMD. So what can we do? We are going to create a transaction. Okay, the contract instance that we created. Here we do functions. We are going to call contribute to build transaction. It's the other way around, I think. parentheses. So what we should provide here in our transaction, we should provide the chain ID first. Our chain ID, you can get it here. Where is it? Here. Yeah, this is the 131337. 31337. Second one, the value, how much Ethereum we want to send. So let's do W3 two-way, and we provide how much. I want to send like 0.000. Spend too much Ethereum on this. Contribute Ether. Okay. And then what can we send? Now we have to specify how many gas we want to spend. So I think 75K is enough. And we have to specify also the gas price, how much we are willing to spend per gas. So it's same W3 two-way and 0.05. Three-way is the unit for gas. We need to look all the nodes of our track the transactions that are sent. Yeah. Where is it? Get transaction count. Is my okay. So we built our transaction, chain ID, the value that we want to send, how much we want to spend, gas price, everything. So now what we have to do is to sign TX and send the TX. We send the TX with a private key, like we do W3 if count sign transaction is TX with the private key. Where is it? Yeah. And now we have to send the transaction. Send TX equal to W3 if dot send. Where is it? W3 send transaction. No, it's not this one. Send draw transaction. And which transaction we want to send? The signed transaction. And we put raw. Transaction. So if you want to print and see the hash, let's do this print hash of the transaction. Hash. We do then px.x parentheses. So everything is okay, everything is all right. Let's run this function. Three. What's the name? Oh, oh. Okay. So we did not match any variant of the bottom get if block parameters. Okay, we have some errors we need to fix. So if we go back to our contract, so this is the right address. Put it. The error is not much variant of untagged in sometimes the errors are not this is our private key. on my address. So everything is okay. So to check some address, check on private key. Value, in ID, value, gas price, ETH GWay, ETH get transaction count. Oh, this is the get transaction count. It's not get transaction block. It's go again. Back. So here we have a gas error. So transaction gas price 5,000. It's too low. Let's add the minimum is which has base fees. Oh, okay. If we put 6 for the gas fees, we go again. Yeah, transaction passed successfully. So if we go here to the node, we will see it. Now this is our transaction. And if we go to our smart contract and we do, which what is the second one here? I will not go to create a function get contribution this one, but we are going to see a get contribution and yes. So we send some Ethereum, okay, to this contract. As we can see here, the balance. So we have a contribution. We contributed to this, but now we need to become the owner. What should we do? We need to send a raw transaction, not through this contribute, but a normal transaction, like a transfer from our address to this contract address, so we can become the owner of this smart contract. So this is our function. So we don't need this function anymore. So we can, I don't know how to do all selection, but I think it's like this and yeah, that's all. Okay, so now we need to send a raw transaction from our wallet to the address directly. So how we are going to do that? We are not going to use the contract instance or anything or the API. It's just from wallet from an address to an address. So just we need to build a normal transaction TX. We build the transaction, we sign it, and we send it. That's it. So it's two. Let me this one. It uses me, disturb me sometimes. So it's two. Here we need to contract address from. This is to from. We don't need to do from because we are going to send and sign with our private key, so we don't need from. So it's just to value how much we are willing to send. So value, let's put W3 to from or to two-way. And the two-way. So we're gonna put 1 ETH. I'm going to send 1 Ethereum to the contract. 1 ETH. Ether here. This first thing, okay. Second thing, gas. So the normal transfer does not consume a lot of gas. So 50,000, I think 50K is enough. Gas price. So it is like W3 two-way. And we are going to put like the previous one, how much? 0.6 G way, okay? So we're going to send to the contract address. The value is 1 Ethereum. The gas price the gas that you are willing to use is 50,000, and we want to pay like 0.6 G way per gas. And we need the nonce for sure. Transaction of our wallet, transaction count, w3.dot transaction count. Yes, for sure. My wallet. This function keeps track of our transaction. My address. This is, and what do we need else? We need the chain ID. It does not matter if you do not put them like in order. Like here, I start with chain ID value and everything here. It's not that big deal, so you don't have to worry about that. V31337. Yes, so to value gas price stance and chain ID. So everything is ready. Just we need to sign ex w3.e account sign transaction is the tx with the private key and sign and sign. Let's name it like that. W3 dot if send raw transaction. Which transaction? It's the sign tx dot raw transaction, and we can do, let me copy paste this one. Print hash, okay, send and sign. Then fine. So everything is ready. This transaction is just we build a normal transaction to transfer money from our wallet to the contract address. So we do this. Let's save and let's run. Python fallback.py. Connected. And this is our hash. Let's go to the node here. We see that transaction, yeah, hash from our wallet to 1 Ethereum, and we spend gas like it's 28,000 for off that. We provide 50k, but the blockchain only consumed only 28,000 of the gas. And if we go here and we receive the 1 Ethereum to the contract, and if we press owner, we shall see our address as the owner, and we are now the owner of the contract. Our address, let's make sure of it. Yes, same. So guys, that's all for this contract for today. Try it yourself. Try it yourself. Try to do the coding yourself. It's like try to build the transaction like this, sign and send them by yourself, so you can understand what is happening exactly. So, and if you need anything, any information, if there is something not clear for you, just leave a comment below, and surely I will reply to you. Thank you so much for watching, and we will be seeing each other soon.